The Earth is the only place in the cosmos that we know has life. And what life it is! Flora and fauna of all sizes carpet the planet, in some places forming dense mats of vegetation, buzzing with animal activity at all levels, while in other places, life barely clings on in the face of extreme environmental pressures. But if we scale down and look at the microscopic world, we see microbes everywhere, literally everywhere, from high up in the atmosphere, including mountaintops, to buried deep in the soil, even way under the ocean, from temperate tide pools to deep-sea hydrothermal vents, from inside the guts of animals to coating the outer surfaces of everything exposed to the wilderness, from your skin, the fur and coat and feathers and scales of every creature out there, even the outside of the International Space Station. The resilience of life, particularly the ubiquity and resilience of microbial life, has led us to suspect that life may be common in the cosmos, particularly the simple, primitive, humble, microbial kind of life. But a new study from Antarctica is kind of screwing up all of these assumptions, and not in a good way. Microbial ecologist Noah Fearer and his colleagues were working near Antarctica's Shackleton Glacier when they took samples from the soil and regolith. Previous research from other sites in Antarctica had produced samples coated with microbes, just like you would find if you sampled soil and regolith literally anywhere else on the planet. But these samples that Mr. Ferrer and his colleagues took were different. Now, most of them also had abundant microbiota, particularly fungi, but some of these samples, taken from the coldest, driest, saltiest regions on Earth, had no microbes at all. This is super weird, because Mr. Ferrer believes this is the first time scientists have ever looked at soil samples that haven't contained any microbes. Although he moderated his statement by saying that they didn't detect any life, not that there was definitely no life present. He said, quote, "We can't say the soils are sterile. Nobody can say that. That's a never-ending quest. There's always another method or a variant of a method that you could try," unquote. And on this note, polar microbiologist Jeff Bowman cautioned about false negatives, saying, quote, "Certainly, there were things there. This is Earth. This is an environment that is massively contaminated with life," unquote. So maybe there were some microbes there in those samples that just weren't detected. In either case, I think the implications are more or less the same. The extremely dry, extremely cold conditions near Shackleton Glacier may be fundamentally, physically prohibitive of life. It may be the case that these conditions represent a hard limit to the abilities of evolution, where it's simply too dry and too cold for living biochemical systems to operate here. Fellow researcher Nick Dragone said, quote, "It's the combination of multiple, very challenging environmental conditions that restricts life more than just one acting by itself. It's a very different sort of restriction than, say, just high temperature," unquote. In their abstract, the researchers said, quote, "Constant exposure to these conditions for thousands of years has limited microbial communities, so that their presence and activity is below detectable limits using a variety of standard methods. Such soils are unlikely to be unique to the studied region, with this work supporting previous hypotheses that microbial habitability is constrained by near continuous exposure to cold, dry, and salty conditions, establishing the environmental conditions that limit microbial life in terrestrial surface soils," unquote. Unfortunately, this has bad implications for the potential of life on Mars and elsewhere in the cosmos. It's been long suspected that large multicellular macroscopic alien life forms are probably exceedingly rare, but alien microbes may be very common, due in part to their extreme hardiness and adaptability. But this study has demonstrated that there may very well be limits here, and that some places, like really cold, really dry places, are just fundamentally not suitable for any kind of life. And this is bad news because Mars is really cold and really dry, and it's also really salty, too. So the microbes that we suspect may exist there may not. The microbes that we suspect may exist in the cold, dry biospheres of Titan or Pluto or other worlds orbiting other stars, there's a chance they may not actually be there. These conditions may be too inhospitable for any form of life. Although I think you would be on strong ground if you were to criticize the claim that these conditions may be too inhospitable for any form of life. Any form of life, that's a big claim there. We only know our type of life, carbon-based, adapted to use water as a solution. There very well may be other types of life based on other biomolecules or that use different solvents to facilitate their reactions. A long time ago, I read a paper about a kind of cryomembrane or a cell membrane that could sustain viable life processes, that you need out of a membrane, but in extremely cold environments. The membrane was composed not of phospholipids, but of some kind of nitrogen-containing compound that could aggregate to get together and form membranes in cryo environments. So there could be another type of life, completely exotic to our type of life, that is adapted to these conditions. But until we discover it, until we see it firsthand and can somehow study it and understand what's going on here, until that happens, it's really hard to say that any kind of life could live in these habitats. So let's zoom out a little bit from our solar system. What is the bigger implication here about the cosmos? Well, the ultimate implication here is that life in the universe may actually be vastly less common than we think, due to the introduction of this ecological boundary. However, we shouldn't lose hope for alien life in the cosmos. At least, I don't think we should. It's entirely possible that some alternative biochemistry may be much more cold or drought tolerant, in which case these implications could be disregarded or at least mitigated to some degree. And on that note, there's always other Earth-like planets that could host carbon-based life, just like us. It's not to say that all life is impossible all over the cosmos. So, what do you think? I've covered a number of news stories in the last 1 or 2 years that have really been kind of a tug-of-war over the feasibility of life in other environments across the cosmos. And this study represents a strong tug in the direction of not feasible. Despite this, the search for alien life continues, and the great game of tug-of-war will continue for the foreseeable future.